All right, everybody. I'm here to talk about HTTP and how that affects you as a user, someone who works on the web, who builds on the web. So starting off, we have the idea that HTTP runs the modern web. It's basically the underpinnings for websites, API services, your mobile apps, all of the background services that happen with those. All of that runs basically on HTTP. But what is HTTP? That itself is a hypertext transfer protocol. It's basically just a set of ways information's thrown across the web. It's a very defined structure that allows an application protocol for distributed, collaborative, hypermedia information systems. There's some key points in that, though. Distributed, collaborative information systems. Basically, these HTTP services can be across the world, but yet one person here in Louisville could access something that's hosted in Japan, and vice versa. It allows all of these services to be basically connected in a web, which is why it's called the web, across the internet, so you can see all of it, access all of it, and use it. Yeah, mind blown, right? But this guy Tim Berners-Lee and the team he was working with, they basically created the initial HTTP spec. With that, they created, the HTTP spec, HTML, associated technology for web serving, and also the first text-based web browser. So all of that is thanks to them, and that's how we basically got started back in the mid to late 80s. Now, all about the give and take, aka the request lifecycle. This is the basic idea behind how the web works. We have essentially a browser that makes a request to a server, and then that server sends back a response. Now, that browser could be any type of client. It doesn't have to be a web browser, but in this case, we're just talking about web browsers because it's easy to understand. But let's dive into this a little deeper. What if we wanted to look up a picture of a kitten? Where would we go? Google, DuckDuckGo, or something like that, some search engine? Well, we type in our request, we find our kitten, right? Yeah. But how did that happen? Let's dive in deeper into the actual requests and responses. So first, we have this is really hard to see. We need brightness. Yeah, that might work too. So basically, here in the green, that is representative of the actual requests. So what we're doing is that we're just saying, hey, we just want the web server, which is this get / and then the HTTP / 1.1. That's just the start line. I think it's not status line. It's a request line for the request, saying, hey, I want to get this index page, and this is the spec that I know. The next line is just saying the host, we want duckduckgo.com. That's basically saying if we hit the server and it knows how to handle more than one domain, we want the server to give us a request for that particular domain, which is duckduckgo.com. And the others are just some content allowing so that we know, aka the browser knows how to handle certain types of content. And following that, the server sends back this nice big response saying, hey, your request turned out okay. Here's a bunch of information for the browser that it might need to know. And then we have a space and then the actual HTML for that page. And then our browser recreates that as a set of visual blocks, pictures, links, all of that stuff comes together through that HTML. Now, you may have seen that get / line. That get is actually a method, a request method, which is basically the primary source of request semantics, which means, in a light kind of way, that our HTTP client, our browser in this case, is saying, hey, I want to get some request. I don't really care about sending you information. I just want to see something. I want to get something back from you. And that kind of semantics for a GET request extends out into a lot more. We have in the original 1.0 spec, we have GET, POST, and HEAD, where GET and POST are mainly the things that you deal with. So if you submit a form on the internet, that's a POST request. We're posting information to that server. And then when we send that information, our server is going to react to it. It's going to take that information and do something with it. In the new 1.1 spec, they added options, put, delete, trace, and connect. It's just expanding the verb, so we have a really nice method that links to a certain type of action, where a delete method will typically signify some kind of action that deletes some record, some type of information that's no longer needed. Now, these aren't the only ones that really are existing. The 1.1 spec allows methods to be created on the fly. So it expects them to be expanded upon and not just be used in these 8 cases. But that's a cool part. So here in this slide, we're just signifying that GET in that our original request is what we were just talking about. So that's cool. Now, headers. Now, I kind of briefly glanced over these earlier just because there's a lot of them. I'm just going to show about 10. Now, these are mainly the basic ones that you'll see most often. Your host, user agent, accept encoding, accept language. Those are all kind of request headers you'll see when you make a request to a server. Your host is saying, hey, I want this domain. Your user agent is usually just auto-populated with whatever browser or user API client that you're using. Your accept is the type of information that you can accept. So HTML is the basic one, text HTML. You can also do images, image ping, JPEGs, all that stuff. That goes hand in hand with your accept encoding, which is where you get your gzip encoding, which allows you to compress all of your data, and then your browser expands it back out to read everything. And then your accept language is your basic underpinning for I-18N, which is your internationalization, where your browser knows that your computer can read German text or Korean text. It knows how to display those properly, so it allows the server to send that if it knows how. In your response headers, a few of those are your server, which is your basic web server, Nginx or Apache. The location, if it needs to redirect you to another page or another site, it'll use that location header to send you there. The content type is just how it replies. And your expires and cache control help your browser cache data locally. So if the server sends those headers and some others, your browser will know that, hey, this data is not going to change a lot. So keep this on your browser so you don't have to get it again. And it helps speed up things. And then these are basic reasons for headers and why they happen. A lot of it is to provide more context to a request or response, to kind of modify how something happens during that whole request lifecycle. And again, we're just displaying these headers in a prominent fashion so that we can see in our original request all of these nice things that happen for us. So we have our expires tag and our cache control, which say, hey, this page isn't going to do anything, but we don't want you to cache it. And its max age is 1, so that's not going to really cache for very long. Because it's a dynamic page, they don't want you to save it locally. But probably all of the images that are on that page will be cached. And then the status codes. Now those are the awesome things that let your browser know how the server wants you to respond, how the request went for you. And there are 5 main groups. There's the 100s that are mainly informational. There's the 200s that are the successful status codes. 300s are redirection. 4 are client errors, and 500s are server errors. Now, more than likely, you all have heard of a 301 redirect. That's, and 302s. Those are in that redirection group. Your 500 server error, that's just a general error, but then you have a 502 is a gateway not found. There's some back-end service that can't be connected to. And then your standard request or response status code is that 200, that OK. That's just saying, hey, browser, everything went all right. You're cool. Keep doing what you're doing. And in our original request, DuckDuckGo sent back a 200 OK, saying, hey, this is all you need to know. Grab everything else. But what if we had requested www.duckduckgo.com? Well, if we see here, we got a 301 moved permanently. That's our 301 direct. And our location header is set here, and it's telling us to hit https://duckduckgo.com. So they don't want us to use that www, which is how we usually set up canonical URLs and all of that for our clients. And putting it all together, this is really the awesomeness that is the web, that all of these things kind of blend together to give us what we know and love. So we have requests that are made to a server and responses that are sent back to the client. Our methods note a type, quote unquote, of request that we want to make. And our status codes send back the type, quote unquote, of response that we're getting back from the server. And our headers modify the request and response. And all of this is defined very nicely in our HTTP specifications. So thank you. Any questions?
Will it ever evolve again? It's at 1.1 right now. Will it go to 1.2? And what would you expect?
What's constantly evolving, the original HTTP 1.1 spec was something called the RFC 2616, which was done, I think, the late 90s or early 2000s. They just redid it into a set of RFCs, 7230 to 7235, or 6 of them in total. And then they have like 4 supplementals as well. Those were just approved and released as done this past July. So those were just updates with how the web has migrated into being used today. And in those is where it says that the request methods can be defined elsewhere. The headers can be defined elsewhere. Like, it's not just what's in the spec, it's what's being used. So it's definitely going to expand into the future.
But the expansions can be more user-driven rather than spec and W3C.
Yep, exactly. The W3C is basically responding to how it's being used by everyone. So if they see that there's a large thing that's happening like caching or authentication, which both have been used prevalently and have been defined in a kind of spec fashion. Those are kind of use cases where the W3C responds and actually defines something that should happen across the board. Anything else?
How would someone look at the request headers?
That's awesome. So we can actually come over here into a browser. So let's start up Chrome real quick. And so I'm going to open up my inspector by hitting Command-Alt or Command-Option-I. And so we see all these requests come in. I'm going to request so we can refresh so we can get that root request. So here's our actual request to Google. If we tap that, we can get all of this information. And make this bigger. So we get all of these headers, and this is our basic request in a nicely formatted fashion. You can see our actual request headers here, where we're sending a bunch of information. Here's all of our cookies for the domain. And here's our host saying that we want on Google, and then here's where we send out that we're using Chrome on a Mac OS X 10.9.4. That's actually the bottom. So any query string parameters that we're sending in the URL, those are right up here. So GWS RD is SSL, so it's just basically a redirect. And then here are the response headers that we get back. Along with that and our actual response, which is our HTML, that generates our nice page here. So if you ever are interested in how things are happening, you can usually come up to View in Chrome, go to Developer. Most of your normal browsers nowadays have a developer option. Sometimes in like the case of Safari, you have to enable that menu option, but it is available to you. So you can actually even set up your phone to be remote debugged on your computer, which is nice for debugging mobile sites. And you can see what requests are failing if something's failing and not working properly. To answer your question, John? Awesome.
What's neat about that is that every single element on that page has that.
Yep.
Every image has those request headers and responses.
So basically what John's saying that what I was talking about initially where it returns your HTML, that's all it returns for that one request. Your browser is what goes back out and finds the URLs in that HTML to request everything else. So any style sheets, JavaScript, your images, any kind of fonts that you might have on the page, all of those are loaded after the fact, which is why a lot of optimizations are going around reducing the amount of requests that you actually make. So if you have a ton of JavaScript files, it's often wise to combine those into one file so that you don't have to make 1,000 requests because you have 1,000 JavaScript files, which wouldn't be smart anyways, but sidebar.
So basically, if you had a page with lots of assets on it, it would be like loading a page 100 times.
Yeah.
Rather than optimizing your website to have 6 resources and it's like requesting 6 web pages instead. So that's a big key optimization.
And then I was talking about encodings earlier as well. Your gzip also helps with optimization. So if you're sending your response in some kind of compressed fashion, most browsers know how to deflate that on their end. So that saves kilobytes in your requests, so that helps speed things up as well. Anybody else? Cool. Well, thank you.